Welcome to breadboarding. In the previous video we got this CGA compatible video controller built on solderless breadboards working in CT.EXE mode, and you can see here. In this video what we're going to be doing is testing the CGA graphics mode with both a custom written CGA test and also some DOS-based utilities, and we'll be fixing some of the problems found. So this is video 56 in the Breadboard 8088 PC series, and this is part 11 of the CGA video controller. If you want to see earlier videos, then there will be a link at the top of the screen, and there's a playlist in the description below where you can see the whole series. And this is part of our high-level plan where we've developed a basic Nanocomp 8088 which had just a LED display and keypad. We then developed this into a basic floppy disk PC able to boot MS-DOS 330 off a floppy disk. And now this is the final part. We've already done the IDE disk controller and booting MS-DOS from the hard disk, and this is the main step really necessary to develop the CGA video controller before we try and run early versions of Microsoft Windows version 1.0 and 2.0. To start with, we're going to have a look at one of the interference issues we had on the display at the end of the last video. So when we got the video mode for the CGA video controller working last time, there was a few issues in that we had some interference on the screen. And you can see here that there's a bit of a flicker or snow as it's known, and there's also two odd characters. So there's an O there, I think, and a tilde symbol. Now there isn't any activity ongoing, there shouldn't be anything writing to the video RAM at the moment, and therefore we wouldn't expect to see this CGA snow. The original CGA cards would have some sort of snow if you were actively writing to the video RAM whilst the CRTC was outputting the display. Now I've looked at this for some time and managed to get to the bottom of it, and let me just explain a little bit of the background. So this is the KiCad schematic, and this dates back almost to about a year ago when we first started looking at this and doing the 8088 CPU. Now the 8088 doesn't have enough pins to actually do the 20 address lines and the 8 data signals that it has, and so what it does is it multiplexes some of the values. So you'll see here that the AD0 to AD7 actually provides multiplexed address lines, and the lower A0 to A7 address lines, and then there's also the A16 to A19 address lines up here are also multiplexed with another latch. Now it uses these 573 latches, and if we just take a quick look at the data sheets of those, and basically what these have is a latch enable here, and when the latch enable is high then it passes the values from one side of the bus through. When it's low then it latches the values. So basically the output only varies when latch enable is high, and the rest of the time it should be stable when it's low. Now in fact there's a signal that comes out of the bus controller that actually handles this, an address latch enable. You can see here signal that serves to strobe an address into the address latches. This signal is active high, and latching occurs on the falling high to low transition. So if we now have a look at this and see where the address latch enable is, so you can see here address latch enable. So we've got the lower A0 to A7 address lines, and we've also got the A19 to A16. Now you should also note that these address lines here, A8 to A15, these are not latched in any way, they're just sort of buffered straight through, and these are actually always wired. So these don't actually suffer from any sort of glitches that might occur during any latching process. So if you have a look at the CT.EXE logic analyzer output, so this has actually got the address latch enable. This has got the main address decoder CGA RAM chip enable, and also this is the 74LS245 data bus buffer on the CGA card. So if this goes low then it basically means that the main CPU data bus will actually interfere with the video signals. And we've also got the address lines down here, and also if we're writing to IO or writing to RAM, and there's also the video sync signal here as well. Now what we can see here is there's an awful lot of activity on the CGA RAM chip enable, and we wouldn't expect anything there given there's no program actually writing to RAM at this point in time. So if we drill down a bit into this, if we look at one of these here, so this particular CGA RAM chip enable going low it's actually for a very short period of time. If you look over here, it's only what, 15 nanoseconds. And if you actually have a look at the address lines, so we've got A19 to A15 here, you can actually see that during this period of time they're actually in transition. And in fact, if we look at the rules for the CGA RAM chip enable, so CGA RAM is defined as a negative logic, so when we have a true here, this will go low over here. So it means we only have to worry about sort of positive rules here. And if you see here that we want A19 high, A18 low, A17 high, 16 high and 15 high. If we look here, you can see that the address latch enable period here, this is when the high value here allows the value to change in the bus. And what we're looking at here is the latched values. This is the main address bus that we're looking at here. So you can see that during this period of time the address really isn't stable, and if we ignored the period of time for the chip enable during this period, then in fact it would be a bit more stable. If we then have a look at another one that we've got a little bit further on here, you can see for a similar period here, if we include a condition to include the address latch enable, such as we only consider the chip enable to be valid when the address latch enable is low, then will this actually cause any problems with reading and writing? Well, in fact, you can see here that this C1, C2 here, this is where the memory write signal goes low. So in fact, there's actually a period of time, about 85 nanoseconds, between this address latch enable going low and when we'll get a write signal. So in fact, if our chip enable includes a condition to include the address enable here, and we'll only actually allow chip enable to be active if address latch enable is low. So we're going to need to add the address latch enable into the decoder PLD, and we're going to need to update the rule to include this for the CGA RAM. So just need to update the KiCad diagram, update the rules for the PLD, and wire in the extra address latch enable, and hopefully this should actually get rid of our stray characters and our snow when we're not actually doing any updating the video card. Okay, so I've done those changes. So if you look at the KiCad diagram, so you can now see I've added an address latch enable to this decoder, and we've wired it into the bus controller over here, so that now has the extra thing we need there for the condition. We have a look at the rules over here. So now we have the address latch enable has been added. This is version 5, I think, of the address decoder. We've added the pin. Then we've just added to our CGA RAM condition. We will only allow the CGA RAM chip select to go low if address latch enable is also low. So I've programmed those and I've put them into the board and wired up this extra address latch enable pin. And I've actually run the test program. If we have a look at the video output, you can see now that we don't have the random snow appearing on here. I do occasionally get the odd random character come out, so there's still something to do with the writing to RAM, but that doesn't appear to be something related to this particular chip enable issue here. If we now just run the logic analyzer output, if you remember before we had, this is over at least 3 or 4 frames, video frames. This is the video sync down the bottom here. So this is over a couple of frames, and you can see now that we don't have any activity on here, and we don't have any activity for the buffer chip here that opens up the CGA card video RAM to the rest of the bus. So it seems to have sorted that particular issue. Now, what I've also done is gone in and updated the test program. So what we'll do now is to actually test more of the graphics, and then we'll try and load up a couple of test utilities under DOS and see whether or not we can get those test utilities to run. So let's take a look at the test program. So this is just an enhancement of the previous test program that we're using. Now I'm going to scroll through this quite quickly. So there's a lot of the test pattern that we had last time. What I've also now done is I've added a test pattern for the 40 column mode. So although we haven't got proper 40 column mode supporting at the moment, at least we should have half the screen will have the test pattern, so we can make sure the test pattern's working before we enable it. And then I've added a number of tests for all the graphics modes. So I'll be talking through these of what the actual individual tests are as we go through. But this should go through a number of the 4-color graphics modes with alternating colors and things. You can see here that our clear screen here, what it's doing is using a pattern which actually has color 0, 1, 2 and 3, so I think it should be black, and then various combinations depending on the palette. And then we've got various combinations of the white background, dark grey background, black background, color set 1. We've got combinations of all these things, and then we'd actually get to the high-res graphics mode. And then they also then expect to have the green foreground for the high-res graphics mode. Then we'll do an alternating 1s and 0s, which will look sort of a hash stroke grey, and then we'll finish. So we'll just run this up now and see what we get. So we've now got the clear screen, so I'm just going to press the key each time and we'll see what results we get. So you can see that the mess that we've got at the bottom there seems to indicate that there is still some sort of issue here, but the top part's okay. It might indicate there's some problem to do with the higher area of memory here. Perhaps some of the address lines and things are messed up. So we'll have a look at that in a bit. Then we've got our blinking enabled. So this is the 40 by 25 mode. So at the moment we haven't changed the clock timing to support the 40 by 25, but that's something that we'll be doing later on in this video. So this is now showing the test pattern for the 4-color mode. So this should be showing something along the lines of the background color and then the various combinations. So this is then a white background. Then this is a different color set. So this is kind of like the cyan color set. This is, I think, black and white mode. And this is another high intensity, another black and white mode. And then I think this is the high-res graphics mode. And then that has ended. So looks like it's working okay. There's a few issues to look into. But what we're going to do is to run up some of the DOS test programs now and actually see whether or not we can get this working. So in order to get this working using the BIOS, I have needed to update the BIOS EPROM, and that's actually involved updating the video section here. So in the video section, this section now, if we're in the breadboard PC, then all of these values now being replaced. So you see here, previously we just had an MDA, but now I've added CGA for all of these. Now these timings here, although it says CGA, are actually the VGA timing. So this means that this output will work with modern VGA compatible monitors and video capture cards, whereas CGA is still a little bit difficult to use. And so with these updated values here and a few other minor changes to do with the BIOS, what this should now mean is when we boot into the BIOS, then it should actually allow us to see the power on self-test messages in the BIOS. Now there's one other change we also need to make to enable this. And in our original design over here, there's actually a link in the, this is similar to what the Compact Desk Pro did. And if you see here, there is a display type, whether it's MDA or CGA. So monochrome display adapter is attached to ground and CGA is attached to 5 volts. So we need to change this link on the keyboard controller from ground to 5 volts. That should mean the BIOS will know about actually booting into CGA mode. So let's just power on the breadboard PC. I just need to type B to boot it into the BIOS. So you can see here it's actually come up in the black and white CGA as it goes through the testing. No floppy in the drive, and then it hopefully should find the C drive. Okay, so that seems to be working. So it's actually booted up into the CGA mode. What I did need to do is to go into the universal BIOS configuration and change it to select CGA. The default didn't seem to be working. Now the only other thing I've noticed here is that the cursor isn't quite right. Because we're using a CGA output but at VGA compatible, we're actually using sort of 16 rows per character because we're double scanning each line. But what that does mean, I think, is that the DOS here is probably positioning the cursor to something like row 8, which is only halfway down our 16 character cell. Now we've got DOS up and running, there are two utilities, one that I used previously. So CT we actually use to test the monochrome display adapter. You can see there's video snow, or video grass I guess, because it's green when we do this, and this will actually allow us to select the various modes. So let's try the various modes. So mode 0 is a 40 character mode. So this is 40 character black and white. So we can see that only half the screen is being used and it's black and white. Then mode 1, which should be color, 40 characters. So yeah, colors appear to be coming out okay there. So mode 2 should be black and white, 80 column text. Yep, so now the bars are going all the way over to the right hand side there. Then mode 3 should be the color text mode. Yep, so that's 80 column text mode. Now we start to get into the graphics mode, so some of these may not be quite right at the moment. So you can see here that it's outputting a number of colors. There is a bit of snow occurring during the video update, and there's also one or two random characters. Now the text isn't quite coming out properly. Now to start with, I did need to make sure that the graphics characters in the BIOS, so there is a character set actually in the BIOS which is used for graphics modes. I did have to make sure that was located in the right place, so I moved it to the right place, but I think some of the pixels are being swapped around a bit when outputting the 4-color mode, and I'll come to that in a few minutes. So the text is almost okay, but the pixel kind of got scrambled up a little bit, so I'll look at that in a few minutes. We can see here that we have actually got the different colors, high intensity colors, different color sets, and the different background colors in high intensity color sets. And then I think this is direct, so this is where it's actually talking to the video card direct rather than going through the BIOS. So that was still working, but we do have these issues with the timing, I think, to do with writing to the video RAM, so we might need to look at that sometime. So that was mode 4, so let's try mode 5. So I think this is black and white mode, or composite. So because we've enabled sort of a black and white composite mode on this configuration, then we'll just get shades of grey. So we again might need to check to see if we need to change any of the palette information around the black and white modes. Again, same problem with the text. Now if you have a look at mode 6, this should be our high res graphics mode. So again, we got video snow whilst the video RAM is being updated, but the text is actually coming out okay. So I think I know what the issue is here. The high-res graphics mode outputs the data actually on the same clock signal as the character generator signal. So the latch used for the black and white high-res graphics is the same as the latch used for the character mode. Now the issue is that the colors actually come from the attribute latch. When it's running medium res color mode, then that's delayed a bit from when this character latch is. So I think we can look at how to fix that a little bit later. Now the green isn't coming out here. This should be coming out in green. So that some of the other colors were coming out okay. So again, I suspect it might be related to the black and white mode here, that there might be something in the test program that's also setting the sort of composite output here. And this is the direct writes, so this is not using the BIOS to update the screen, it's actually using direct writes to the video RAM. So these initial tests show that we've got pretty good compatibility so far, but there's a few issues we need to fix, and also need to change the clock so that we can support the 40 by 25 column mode in the full width of the screen, so we need to adjust the clocks for that. Once we've done all these changes and fixes, then going to run a utility called CGA Comp, and this basically tests compatibility of the card with a number of issues, and so hopefully at the end of that we'll actually have a much better idea of how well our card is performing. So we're up to about 19-20 minutes now, so I'm going to break the video. There'll be links to a playlist in the description below, and there have been some links at the top of the screen when I've mentioned earlier videos. So if you don't want to miss out on future videos, then please hit subscribe, and if you can hit like, it just helps to make the videos available to more people. Thanks for watching.